So, hello everyone and welcome back to my channel. In today's video, we are going to break down a very interesting and advanced coding problem, counting substring that have dominant ones, meaning the number of ones in the substring must be greater than or equal to the square of the number of zeros. Okay, so we will walk step by step through the logic, understand why the basic approach fails, and then reveal a highly optimized solution. So let's begin the deep explanation. Okay, so in the first line we have written class also. We have just defined a class. Okay, after that we have defined the function, that means diff number of substring self comma s. Okay, here we create a function that takes our binary string s and return the count of all substrings that satisfy the rules once which is greater than or equal to zeros. Okay, in the next step we have stored the length of a string, that is n is equal to len s. Okay, here we have stored the length of a string for future calculation. This will help us avoid repeated length calculation. Okay, on the next part with we have check a condition, like if the string has no character we will take a return 0. Okay, so we have to write down that if n is equal to 0, then we have returned 0. If the if the input is empty, there are no substring, so the answer is 0 right away. Okay, in the next part, there is also a condition that if the string has no 1s, then no substring can be dominant. Okay, that's why I have written if I is not in s, return 0. Okay, here basically as a substring must satisfy ones greater than equal to zeros. If there are no ones, the left side is always 0 and the right side is at least 1 for any substring with zeros. Okay, so the result is 0. Okay, okay, so come to the point, next point, that is count all substring, okay, that contain only one. So we have written as 0, I is equal to 0, while I is less than n. If s equal to I, si is equal to 1, j is equal to I, while j is less than n and j is equal to 1 and j plus is equal to 1. Okay, I is equal to j minus 1, and in the next part and else is equal to I plus is equal to 1. So here we have checked three conditions, if, while and else. Okay, so in this part we identify continuous block of ones, a block of length l produce l into l plus 1, l plus 1 divided by 2 substring. Okay, all such substring contain 0 zeros, so they automatically satisfy the condition. Also we added them to our answer immediately. This step handles at least half the valid substring in the most case. Okay, come to the next point here. Okay, so we have just collect the position of all 0, so that's why we have written 0 is equal to I for I. Ch in enumerate, yes, if ch is double equal to 0, z is equal to len zeros. Okay, here we explain the we list all the indices which where zeros appear. This let us know exactly where zeros lie without scanning the string repeatedly. If z is equal to 0, we would have written earlier, so we continue. Okay, in the next part we will prefix sum of ones. Okay, like prefix is equal to 0 into n plus 1 for I dx in the range n, prefix I dx plus 1, prefix I dx plus 1 if yes I dx double equal to 1 else 0. Also we have checked a condition. Here we build a prefix sum array to quickly compute ones in substring. Yes, l r is equal to prefix 1 r plus 1 minus prefix 1 l. Okay, this allows 0 1 retrieval of ones in any substring. Okay, we should avoid the time complexity problem too. Okay, for that we have written down that. Okay, in the next part we have just limit the minimum number of 0 to consider the value. Okay, so here we have written limit is equal to in n n into 0.5 plus 3 and limit is equal to mean limit comma z. Here the condition is once is greater than equal to 0 square, as 0 square grow too fast. Like for example, 100 zeros needs 10,000 ones, and 200 zero need like 40,000 ones. Okay. Since string length what less than equal to 40,000, so we never need to check substring with more than about whole square n, which is related to 200 zero. This is critical for avoiding TLE, that means time limit exceeded. Like we have faced some problem like time limit exceeded when we submit the answer. So that's why we have just taken that limit. Okay. After that we have start processing each possible zero count z. Okay. So for z in the range I comma limit plus 1 and need is equal to z z. Okay. Here we have for a substring with exactly z zeros, we need at least z square ones. Okay. For next step we have just for each group of z consecutive zeros, we have written the for k in the range 0 comma z minus z plus 1. Here every substring contain exactly z zeros must include zeros. Okay, like for example like zeros k comma 0 k plus 1 and zeros k plus 1 minus z here. Okay, so like we examine each such zero block. After that we determine the allowed left boundary here. That's why we have written that part, that left 0 idx from the line number 43 to 44, and also include the part 47 to 48. Here we valid substring start L must be, and after the previous 0 to avoid adding an extra 0, or before or at the first 0 of the block. So L range between left mean and left max. Okay, after that we have determined the allowed right boundary. Yes, here. Okay, from the line number 52 52 52. Okay, so here we validate substring in R must be after the 0 of this block or before the next 0. So R range between right mean and right max. Okay. After that we use a forward moving pointer to avoid TLE. That's why we have written pose is equal to right main. For each left boundary L, we find the smallest r such that once L dot dot r is greater than equal to z square. We never reset pose backward. This massively speed up the solution. Okay. In the next part, we scan through valid L value. That's why we have written the thing like in 58 for L in the range, left mean, left max plus 1. Here we check all possible L for this 0 block. Okay. Now move to the pose until the substring substring and meets the requirement. Okay, in line number 63, like 63 and 63 once if once and s 63 to 67. Here we keep increasing r via pose until the substring containing enough ones. Okay, after that we count all valid r value. Here we have written 68 to what 60 like say here yes 68 to 674. Okay, so once pose satisfy the condition. Okay, pose as we have means comment out that once pose can satisfy the condition, every r is greater than equal to pose is valid. So the number of valid substring right max minus position plus 1. So if pose surpasses right max, no future L can satisfy the condition. Okay, so break we have just break early. Okay, after that we return the answer, that is return else. So here after evaluating all cases, we return the total number of dominant substring. So in this question we have a conclusion part, that is like we first count all substring with only ones because they are always valid. Then we use an advanced technique combining zero index tracking, prefix sum, third part, square root of n optimization, or two pointer expansion. Also we have checked that this avoid checking all 0 n square. substring and bring the like complexity down to 0 n into n, okay, which is fast enough for input size up to like 40,000. So this optimized method ensure we never hit that like time limit exceed and always get the correct result. In this question, we have point out the time limit exceed like sometimes like five times. That's why we have taken that point and solve this question. Okay, so that's all from my side. Okay, please like, share, subscribe my channel. Okay, have a great day.